Hello, everyone, and thank you for joining today's session. I would like to start by saying that open source software has become, in the past few years, an indispensable part of the software industry. It has been fueling and accelerating development agility and productivity in ways that are arguably not possible with, non-open source means. Open source has therefore been reportedly estimated to encompass a significant percentage of developed software. Quotes about 60% to 80% are quite common, and this makes it a true mainstay of the software business. That being said, open source has special characteristics that arguably cannot really be treated and accommodated with traditional methods that are used for the development of proprietary code. For example, ownership and authorship, licensing, quality, and perhaps significantly, security. I need to place what I would call a puissant attention on known vulnerabilities and their visibility, vulnerability fix availability, and post-release monitoring. All of that prompts a pronounced need to focus differently on people, on processes, and on technology. With regard to security in particular, by the way, open source usage is increasingly getting media, general populace attention, following the variety of reports of data breach incidents associated with open source vulnerabilities. As many of you likely know, such incidents have affected millions of individuals as well as organizations and services worldwide. But at the same time, organization development is striving to bolster performance in an effort to attain maximal productivity, and doing so while pursuing agility. So in the wake of the increased usage of open source and the perhaps unprecedented business pressure on development teams, addressing objectives has become, more challenging than probably ever before. A new report by WhiteSource presents some interesting findings in addition to conclusions and insights concerning the state of open source vulnerability management. It is based largely on a survey of hundreds of developers from North America and from Europe, and the developers represent various organization sizes, industries, and developer experience profiles. The report itself discloses a wealth of findings and observations regarding the manner that open source development is implemented in organizations. In this session, what I would like to cover, or perhaps review, better put, I would like to touch upon major developer contemporary practices and perceptions that concern the challenge of managing open source security. And in the process, we will also highlight steps that are recommended to deal effectively with that challenge. So let's please move to our first slide to begin with our journey. So this slide presents a quick rundown of major findings, takeaways, if you will, of the report, each of which will be covered throughout this presentation in greater detail. The findings themselves have translated into a number of insights that have contributed greatly towards, I would say, an establishment of recommended processes, practices, and tools which are valuable as well as effective, and importantly, they are practical. Here is the rundown. First, reported open source security vulnerabilities are on the rise. It's not just about the sheer number of vulnerabilities. It's really about the nature of vulnerabilities that exacerbates the effect and challenge, for example, the notion of known vulnerabilities versus potential vulnerabilities is something that comes to mind here. Number 2 on our list is the absence of standard practices and developer-focused tools leading to inefficient handling of open source vulnerabilities. This, in other words, means that a lot of time is spent, but it does not commonly result in the required outcome. In the attainment of the set objectives, or perhaps does not necessarily yield the result in an efficient manner. And we will touch upon that in much greater detail as we go through the presentation. Number 3 is about prioritization. Prioritization is, as noted, crucial to ensure that companies address the most critical vulnerabilities on time. But as was noted with regard to a previous item, it's not just whether one should prioritize vulnerabilities, it's really more, and then how. Because addressing all reported vulnerabilities while maintaining other goals is not really believed to be a viable proposition. It's an interesting concept, and we will definitely look into this as we move through the presentation. And last but definitely not least on our listing is that prioritization based on usage analysis can reduce security alerts by a significant percentage. And a special approach to prioritization must be implemented, one that could realize a positive effect on time, on prioritization, and importantly, on remediation. Let's please move to the next slide to expand on the first item on this list. So, vulnerabilities are an important characteristic of open source security, and the impetus driving a significant part of the attention warranted by this. Let's please move to the next slide to examine how such rise or how such an increase is being manifested, what it should imply, and why it should be of interest. So let's move to the next slide. What we see here is a chart, and as the chart shows, the number of disclosed open source vulnerabilities increased by over 50% in 2017. I would say that even with killiards of vulnerabilities reported every year, not only is such a rise significant compared to the previous year, it is even more pronounced when we compare the overall number of recently reported vulnerabilities to those reported just a decade ago, where they were around the 1,000 count. There are some aspects that are worth noting here. First, I would say that the rise manifests a continued trend that highlights a growth in the number of reported vulnerabilities, but the emphasis on reported was not misplaced here. These are no potential vulnerabilities, but rather real vulnerabilities which are visible to everyone, and as such, they likely demand swift attention and action. Another aspect worth noting is what kind of reported vulnerabilities are there? Security vulnerabilities can result in severe threats, which encompass identity theft, unauthorized access to confidential or otherwise sensitive systems and data. And this leads to risks encompassing data and identity theft, impact to data, service disruption potential, all of which can seriously affect society in general and organizations and individuals in particular. Furthermore, and perhaps as demonstrated by incidents of late, exploited security vulnerabilities can additionally result in substantial reputation damage to pertinent parties, such as service providers, financial institutes, and more. So this is a significant aspect to note. And finally, I would say, or perhaps ask, what does this rise mean in terms of security? The detail suggests a marked increase in the attention and importance that was placed on open source, but establishing its true significance or lack thereof requires us to really ask whether and to what extent is the developer community affected by such an increase. I think that in order to assess that, let's please move to the next slide. The report's findings, in my opinion, they clearly indicate, well, especially with over 96% of developers relying on open source components, they indicate that the rise in security vulnerabilities is likely to affect a substantial percentage of software developers. In fact, a closer examination of the findings showed that the large majority of developers either use open source components all the time or very often. In order to perhaps better cerebrate over the numbers, it would help it will help us present them as follows. Let's perhaps use this type of presentation. For every developer who does not employ open source components, there are roughly 30 developers who do, most of whom employ components all the time or very often. Perhaps using this example or this portrayal, we could get a better understanding of the stark differences that this chart presents. But I think that in light of such numbers, it has really become highly important for organizations to be cognizant of the characteristics of open source development. But unfortunately, and as perhaps various studies and observations showed, well, they have showed thus far, a notable gap has been commonly espied between the perceived and actual usage of open source software. This is even more pronounced when reviewing observations made by managers and developers, with some indicating the perception to be much lower than in reality. Now, such a gap can be extremely problematic, since proper awareness to the actual employment of open source is key to appropriately establish or adopt effective open source best practices. And this becomes further pronounced when we examine the prevalence of security vulnerabilities in popular open source projects. In order to review that aspect in greater length, let's please move to the next slide. This is a significant point. While it only takes a single vulnerability to render a project vulnerable, findings show that there are about 8 vulnerabilities on average per open source project. More significantly, though, while roughly 7% of all open source projects are found to have one or more security vulnerabilities, a larger percentage, 32% in fact, of the top 100 projects, or perhaps, well, it is almost 1/3 of the top projects are vulnerable. Vulnerabilities are therefore clearly not solely attributed to low-profile projects. One could even contend that top projects are more vulnerable as they garner a higher level of attention, and described vulnerabilities arguably warrant faster reaction, especially given their visibility and exposure. The apparent, and I would add parlous, potential of such vulnerabilities is, however, not the only important aspect of open source security. There is more to it. This is better demonstrated with the next slide. So let's please move to the next slide. As the slide shows, over 97% of the reported security vulnerabilities have a suggested fix. It's a crucial point, since it essentially means that not only is there a viable approach to address most vulnerabilities, but there is, and this is given the vulnerabilities visibility, a responsibility, no less than that, a responsibility to do so as quickly as possible. The nature of open source vulnerabilities, I believe, calls for organizations to reconsider any existing approach to address security vulnerabilities that has been put to use with non-open source software development. And this could in turn call for new policies, processes, and also new tools. But the rationale for the latter, in particular, new tools, becomes more pronounced when factoring the criticality of a quick reaction to the emergence of security vulnerabilities, and perhaps even more importantly, the negative consequences when neglecting to do so. Let's please move to the next slide. As the slide shows, or perhaps implies, obtaining the information that is required to help us deal effectively with open source security vulnerabilities is paramount. But it can also incur a non-insubstantial effort, if I may say so. And this is further amplified by the requirement to maintain effectiveness throughout the software development lifecycle, including, and most importantly, post-release. The cost of software adjustments and fixes increase the later they become incorporated. And as a result, it becomes not merely advantageous, but downright vital to seriously consider employment of means that would not only enable ample management of multitudinous vulnerability repositories, such as databases, security advisories, issue trackers. It would also enable automation and facilitate the automation of such management. Up until this point, we've reviewed key facets that are associated with open source security and the challenge that open source security poses. I believe it's time to examine now how developers have been coping with that challenge. So let's therefore move to our next section and the next slide. So, as I said, it's about time to review how developers are coping with the challenge or the challenges of security vulnerabilities. I think that as the second takeaway on our list hints, developers are not really efficiently managing open source vulnerabilities. This is arguably the end result of a series of aspects that we will cover in the next few minutes. Why actually is efficient management important? I would say that in plain words, any inability to address vulnerabilities in an efficient manner, it would mean that the developer might not be able to accommodate objectives otherwise possible. This would potentially reduce productivity, it would impede agility, and much more. So in this section, what we will do, we will reveal a raft of the important points. First, I would like to touch upon the key challenges that are noted by developers in regards to open source. Next, I will address the time spent by developers on open source security vulnerabilities. And lastly, I would like to advert to approaches that are commonly implemented by developers to address open source security vulnerabilities. So all in all, it should be pretty interesting stuff. Let's please move to the next slide. What this slide presents is how developers rate select aspects associated with open source software development. Namely, this is integration, vulnerabilities, security vulnerabilities, functionalities, licensing compliance, and component selection, each of which represents a significant aspect of the open source development lifecycle. The challenges are portrayed according to three different organization size classes. If you look at the charts in front of you, the blue bar denotes the rating by developers in organizations that have between 51 to 200 employees. The orange bar denotes organizations with 200 to 1,000 employees, and finally, the yellow bar denotes organizations with 1,000 employees or more. Now, having said that, the findings clearly indicate that the security vulnerabilities, as well as integration perhaps, are both aspects that are rated highly by developers, and this is further accentuated in organizations with 200 employees or more. Licensing and selection were not rated as highly important as they are. And I think that to conclude this slide, at least a key takeaway would be that the larger the organization is, the higher focus on vulnerabilities and integration. And this is even further pronounced by developers with more experience. It may not be highlighted on this slide, but it definitely takes some insight from results that were obtained as part of the survey. In addition, I would say that well, actually, even before I elaborate on that, I think that the key question would be, how does such rating affect the time that is spent by developers on security vulnerabilities? And perhaps it would be best to move to the next slide to observe how this is done. So let's move to the next slide. The findings on this slide, they indicate that on average, developers spend about 15 hours per month on open source security vulnerabilities. And in the 15 hours, they cover a myriad of aspects, such as reviewing vulnerabilities, discussing them, remediation activities, and so forth. Importantly, over 98% of the developers that were surveyed they spend some time over security. So we're not just talking about a majority. We're talking about practically all of the developers involved in the survey. 73%, roughly 73%, spend over 10 hours. You could liken that to 1 day, if you will, per month. And 43% spend over 20 hours per month. 15% spent over 36 hours per month. And perhaps alternatively put, that would translate into 4 days or more every month. That is staggering. Another way actually to look at these findings is to say that for every developer that does not spend any time on security, there are more than 70 who actually do spend some time, just to give some way to assess the ratio here. And as the chart on this slide displays, the more experienced the developer is, perhaps with the exception of those with over 10 years of experience, I would say that the more time is spent over security vulnerabilities. These findings demonstrate how much time is spent, and they underscore the substantial onus and toll that is placed by security on developers. But the next slide will highlight how the time is actually being spent. So let's move to the next slide. What we see on this slide is basically information that tells us the following thing. In response to the question, what is done with a vulnerability, or when a vulnerability is found, practically all developers, all but 1%, are responsive and reactive. Roughly 1/3 are researching. Over 45% of developers spend some time remediating open source security vulnerabilities, and almost 20% elect to report to other teams or to another manager. Importantly, merely less than 4 hours, 3.8 hours to be exact, per month are spent by developers on average on remediation activities of open source security. And while the observed overall responsiveness looks quite positive, I think that given the nature of open source reported vulnerabilities, and especially given the availability of fixes, the numbers by and large exhibit a sense of inefficiency. For example, a larger number of developers involved in remediation would potentially enable a broader coverage and perhaps a much more accelerated response. It will also be of interest to note that details vary depending on the classification of the results. I will not expand on that, but perhaps you should consult the report to see additional information that is provided with regard to different classifications, because it proves to be very interesting when you look into the more nitty-gritty details. And this, for instance, is further manifested through the reaction time demonstrated by organizations, where practically half of the organizations were noted to replace a component immediately, and with the rest reporting over a month or within a month to do exactly so. And that is a bit of concern given the exposure that each of the reported vulnerabilities has. Now, by this point, the challenge and the challenge severity that is encountered by developers who endeavored to deal with security vulnerabilities should be conspicuous. So in the next section, we will review the viability of prioritization. Prioritization is a means to facilitate vulnerability management, and we will expand on that in a moment. So let's please move to the next slide. This represents our third takeaway, and it highlights the significance of prioritization as applied to security vulnerability management. What I would like to do in this section is to explain how prioritization is observed to be performed by developers at present. I would like to also add what are the salient challenges that concern prioritization of security vulnerabilities, and finally, why such challenges have not been accommodated effectively thus far. Let's please move to the next slide. The The quiddity of this slide is that dealing with security challenges calls for an open, flexible approach, I would say. The marked rise in the number of security vulnerabilities in the past few years amplified the difficulties that are already encountered by organizations worldwide. Those organizations are attempting to address reported security vulnerabilities, and the problem does not solely lie in the sheer number of vulnerabilities, as I noted early on. It is one thing to set out to address all security vulnerabilities, but it is a totally different thing to set such an objective with the concurrent goal of minimizing response time. And I would add to that, maintaining development agility. This is pretty significant. One must review alternative approaches to deal with vulnerabilities given the delivery goals and the resource bandwidth which is available. So consequently, prioritization of vulnerabilities seems, it looks a viable approach to address the challenge. But that said, prioritization preferences vary greatly among organizations, among teams, and they also depend on the use case. Furthermore, prioritization, and especially in multi-team environments, can, and I would argue that it is often so, it is influenced by subjective prioritization arguments. And subjective prioritization does not exactly help streamline remediation processes. The variance among prioritization options was clearly evidenced in the survey's findings, and I will hopefully be able to expand on this in the next few minutes as well. So let's please move to the next slide and review how all of this comes into play. What the survey results show, among other things, is that developers prioritize remediation of vulnerabilities based on a variety of preferences. And importantly, a large percentage of such preferences are not security-oriented or even business-oriented for that matter. There are 6 options that were noted by developers with respect to their prioritization preference or perhaps practices. And they include the following: criticality of the project that might be impacted by vulnerability, which is a business-oriented metric; availability of the suggested fix; perceived impact of the vulnerability to projects; number of software libraries containing the vulnerability; the severity of the vulnerability; and last, arguably least, creation date of the vulnerability alert. Nonetheless, each of which of these options is considered to be a viable option for prioritization, and was noted as such, as the detail shows. However, a closer examination of these options and the portrayed results suggests that they can be classified really into 2 categories. One would be security business-oriented, and the other would be operation-oriented, in lack of a better term. The former, security business-oriented, would include criticality of the project that could be impacted by a security vulnerability, the impact, the perceived impact of the vulnerability, and the severity of the vulnerability, all 3 of which contribute towards the business-oriented or security-oriented class. The remaining options, including the availability of the suggested fix, the number of software libraries with the vulnerability, and the creation date of the vulnerability alert, they are all parts of the what I call the operational or operation-oriented class. And as the chart shows, well, it may imply that at first, but it really shows that just about more than 50%, more than 55%, in fact, of the preferences concern the security-oriented preferences. And this means that almost 50% of the priority preferences are associated with operational drivers. And this can help explain, in part, some of the ineffectiveness that I and others actually attribute to contemporary prioritization of security vulnerabilities, which arguably in turn results in an inefficient practice as well. The next couple of slides attempt to elucidate some of the challenges that are faced by organizations. Those organizations aspire to accommodate security vulnerabilities in a better way, in a much better way. So let's please move to the next slide and review that in greater detail. What this slide shows or depicts is the common way of handling security vulnerabilities, the responsibility, I would say, for reviewing security vulnerabilities, assessing their severity and impact on projects. All of this has been largely placed in the hands of security personnel, and for a good reason. Maugre the significance of their role, however, I would say that the people mostly involved in the selection of open source components associated with the reported vulnerabilities are not security personnel. And the interaction among the different teams constituting the workforce, that workforce which is tasked with the deliverables, the deliverable release timetables, this is not streamlined. It requires an effort to realize an agreement concerning the security-oriented objective attainment and verification. I would add to that prioritization activities. And this represents a gap. This gap, the gap between teams, is even further accentuated, as can be seen in the next slide. Let's please move to that slide. So what we see here is basically that security, development, and DevOps teams are, well, it doesn't really show that, but these three teams are arguably aligned regarding the overall organization objectives, but differences are commonly and perhaps unsurprisingly observed regarding any guidelines and preferences that are touted by each team in order to attain such an objective. The differences, however, among security and development and DevOps, they are also reflected in the team size and consequently in their practical ability to influence other teams. So while not necessarily observed with all organizations, it is quite common to encounter what I would call tempestuous discussions revolving around prioritization of security vulnerabilities, and those can quickly escalate without effectively reducing the effort invested in addressing security vulnerabilities. I would also add that it is observed that a key reason perhaps underpinning such a situation stems from a prioritization arguments that are being largely subjective rather than objective. This is a key notion that I will touch upon in a moment. The distinction here is extremely important and is further explained in the next slide, which highlights the concept, the very critical concept of vulnerability effectiveness. Let's please move to the next slide to review that in greater detail. So this is a build-up slide, and as the build-up progresses, I would like to say a few words about the crucial facets that are conveyed through this very slide. The sheer number of security vulnerabilities presents organizations with several key questions, which reflect what might appear to some even, I would say, as an insurmountable challenge. One would be, can you deal with all vulnerabilities? The answer to which is probably unlikely. The other would be, which vulnerabilities are or constitute real vulnerabilities? This is a good point. Not really much to say beyond that. And which vulnerabilities should be addressed first? Well, I would say that this is another good point. What could really one do to effectively deal with such a quandary? They could obviously reduce the count of vulnerabilities to include only those calling for immediate attention, and they would probably start with those that are confirmed to constitute a real risk to the pertinent application. We call such a vulnerability an effective vulnerability. We also think that by focusing on effective vulnerabilities, or let me perhaps dub it vulnerability effectiveness, if you will, the organization could realize better development effectiveness. This would yield better efficiency, which in turn could be leveraged to realize increased productivity. Most importantly, vulnerability effectiveness could really be used to realize better security. Directing available resources to manage the vulnerabilities that matter most, rather than spreading the effort in a non-optimal way to encompass vulnerabilities that should be prioritized much lower, if at all. So this is a nice idea. It definitely is. But how does vulnerability effectiveness materialize from a mere concept into a practice? Let's move to the next slide to review that. So what we see on this slide is that vulnerability effectiveness represents a practical way to prioritize vulnerabilities. Practical is another way of saying a objective. A reported vulnerability in an open source component is deemed effective if code that pertains to the vulnerability can be referenced from proprietary code. I would add to that that importantly, references can be either direct, as in a direct function call, or could be indirect. And this would manifest through indirect or transitive dependencies. A reported vulnerability will be deemed ineffective if the proprietary code was found to make no direct or indirect calls to the reported vulnerability code. So being able to identify, and especially within the context of a given project, being able to identify if a reported vulnerability is effective or ineffective, this has a huge value proposition because it serves as a means to establish an objective metric, as I noted, for prioritization that helps assess not only the actual severity associated with a reported vulnerability, but also helps to indicate whether a reported vulnerability can be, well, effectively innocuous to the project. And this would consequently help the organization prioritize vulnerabilities based on their actual objective impact. This is not the theoretical, not what would otherwise be dubbed a subjective manner. Why am I calling it subjective? Because it often involves an effort to justify the reasoning behind the prioritization over prioritization or downplaying of its significance. And with effectiveness or with vulnerability effectiveness, it becomes possible to depend on an objective metric that would be used to streamline discussions that would otherwise take place among different teams and streamline the process that, well, basically all organizations are arguably endeavoring to realize. Such a capability can be a godsend to development teams. Those development teams seek a better way, obviously, to deal with security vulnerability. Well, you know, a question really arises, though, given the discussion that we had thus far. Regardless of the theoretical value underlying such an ability, can the actual value be assessed as well? This is a crucial question, and it's unsurprising to be brought up at this point. So let's please move to the next slide and find out. The detail that is presented on this slide indicates that a major part of the reported open source vulnerabilities are found to be, dramatic pause, ineffective. 70% of all vulnerabilities, to be more precise. And I think that interestingly, results obtained from studies that WhiteSource conducted on vulnerability effectiveness, and perhaps more importantly, results that were obtained from real-life implementations, they present evidence suggesting that an 80-20 or even a 90-10 ratio is not uncommon. This is huge, really, and it underscores the fact that 70-30 is not really something that could be regarded optimistic. But even a conservative assessment of 70-30 ratio, this would translate still into over 10 hours per month saved per developer on security vulnerabilities. More than 10 hours per developer per month. Let's please move to the next, or perhaps the final section of this session. So, thus far it has been contended that a viable prioritization method for security vulnerabilities can likely save significant developer time and would likely help to potentially increase productivity. What I would like to cover in the next slide is a few notable findings that serve to highlight what I consider to be important facets concerning the implementation benefits that are associated with vulnerability effectiveness. So let's please move to our next slide. This slide brings this discussion to a certain closure, and it does so by sharing some information, illustrating information that would help garner a better view of the benefits associated with a real-life technology. Effective usage analysis is a technology by WhiteSource. It enables organizations to objectively, this is important, objectively prioritize open source security vulnerabilities, and it is done based on their analyzed severity and impact. Prior to launching this capability, WhiteSource conducted a very detailed and comprehensive beta that spanned a multitude of organizations, applications, and projects. And the data that was obtained throughout that beta illustrates the importance of such technology. Let's cover some of the key findings here. All analyzed projects were found to feature reported vulnerabilities. This would indicate that the increasing prevalence of the reported vulnerabilities is definitely not exaggerated. I would not say that with apodictic certainty, but it is definitely something that proves to be striking evidence. About 90% of effective and ineffective vulnerabilities were detected through transitive, which is another way of saying indirect dependencies. Now, the significance of this finding cannot really be overstated because it is crucial to assess the effective severity of reported vulnerabilities by analyzing not just the direct paths from proprietary code to open source code, but through a circuitous path as well. And this is the critical aspect to be clear. In addition to that, what is noted here is that 86% of all vulnerabilities were found to be ineffective. And this would prove, as I noted just a few seconds ago, that the 70-30 ratio between ineffective and effective vulnerabilities, it really may indeed be a conservative estimation. And finally, 64% of all analyzed projects, and that's almost 2/3 of all projects being analyzed, 64% were found to have only ineffective vulnerabilities. And this allows, in my opinion, for unprecedented prioritization flexibility. This could translate into substantial savings. And to finalize this and to provide a bottom line for this discussion, I think that the comprehensive implementation during the beta underscored a number of hallmark features and hallmark benefits that were noted by customers, namely, an ability to facilitate remediation of security vulnerability cases. This was very high on the list of benefits that were noted by customers. In addition to that, noteworthy was the ability to showcase the value of security improvements to managers and teams. It is, as probably all of you know, not a straightforward thing to translate security in a way, in a manner, in a package that could be easily conveyed to decision makers regarding its value, regarding improvements, and being able to showcase value of security and actions that are taken in light of security prioritization. It's something that is not just interesting, but could prove to be extremely helpful. Next, I would note the ability to realize better prioritization of security vulnerabilities. This is obviously unsurprising given the title of this session. But finally, I would note the ability to obviate unnecessary work on the vulnerabilities that are deemed ineffective and even much less prioritized. So with that, I believe that I've concluded this presentation, and I will return it back.
Well, thank you very much, Rami. A great presentation. You know, guys, I was just reading another report today about open source usage, and I should also add, you look at the recent IBM acquisition of Red Hat, Microsoft's acquisition of GitHub. So many dollars being put in the Heptio acquisition by VMware. These are all about open source at some level, and the open source vulnerabilities is really going to be a key security issue for us all going forward. So thanks very much. We do have a few questions here, if it's okay. My first question comes with this. How does a real life method for prioritization, what does a real life method for prioritization look like?
A real life method for prioritization?
Yes.
Oh, so I believe that well, a real-life method for prioritization should combine several aspects, several essential aspects. One would be an ability to store and leverage knowledge on reported vulnerabilities in open source components that would allow for the establishment of vulnerability effectiveness. In addition to that, an ability to analyze how proprietary code references code in reported open source vulnerabilities based on the knowledge is an obvious addition, but it is not enough. In order to truly provide something that accommodates the requirement here and reflects a real-life method for prioritization, I would also note an ability to classify analysis findings based on severity, ability to convey those results that were associated with the findings in a manner that allows for decision making, because after all, the purpose of this process is to equip the decision makers and developers as well with the ability and the knowledge to make prioritization driven decisions that will streamline the processes and allow them to cover more in less time, and definitely sustain the agility that most, if not all, organizations are striving to achieve. Finally, I would add an ability to feature the detail provided by analysis and alerts, and also share such findings and details with other teams through a UI, through reporting, and probably also using programmatic means that would allow extraction of the detail and the ability to funnel it to external applications that could be used for whatever purpose the organization is looking for. I hope that provides a rather neat packaging of the response.
I think that's great, Rami. Got another one here for you. So you discussed the bridge about bridging the gap between the different teams is a must. But what is needed in order for security not to become a barrier for agility in the development life cycle?
Yes, so yes, indeed. I think that in order to facilitate the way security is incorporated in the software development life cycle, it would be recommended to do the following, to pursue a couple of objectives. One would be sharing of responsibility. I cannot really stress enough how significant this apparently simple concept is in an effort to streamline security-related processes. It is not enough to merely delegate responsibilities as some consider to be viable. I truly believe that it is crucial to seriously consider ways where responsibility could be shared across team members. And one way to do so is by leveraging tools that could either automate processes or convey a status of the process. But this is not alone in this type of recommendation. In order to bridge a gap here between or among the different teams, it is also critical to allow for shifting left the discussion surrounding security vulnerabilities. Now, it is quite obvious that by dealing early as possible with any security concerns, one could expect to minimize potential adjustments and consequently any costs. But it is also important to accentuate how tools here, in this respect as well, could make a difference, and they could make such a benefit truly eventuate. Last, I would note the tools, actually. I just mentioned them, but coming to think about that, I would expand on that by saying that the tools we should look for are not just tools for their own purpose. In other words, it's not to have tools to report on findings, but tools that could truly facilitate creation of the prioritization that customers are seeking. It should be based on vulnerability effectiveness, and all of this could truly, tremendously help realize the points that were highlighted earlier And as I believe I noted several times, it would streamline the preference establishment and would also enable sharing of responsibility in the best possible way.